Good morning, my dear students. Today we will be discussing about the balancing of chemical equation, right? Here, our Cornelia is available for volunteering the board writing. Hi, Cornelia, are you ready? Right. So you can write down balancing of chemical reaction. So in this case, we are going to focus on redox reactions. Take down redox reactions. Can you define a redox reaction? For example, reduction and oxidation. Put oxidation and reduction this side. This side. Oxidation, put two columns. Oxidation and reduction. What do you mean by oxidation? Addition of oxygen. You can put plus O. And removal of oxidation is reduction, minus O. Then removal of hydrogen. Removal of hydrogen. Okay. So that is reduction. Addition of hydrogen is reduction, removal of hydrogen is oxidation. Then in terms of electron, we can define the oxidation as loss of electron. Put minus E, means loss of electron. Write boldly. Then addition of electron is reduction. And in case of oxidation number, how we can define oxidation? Increase of oxidation number, right? Decrease of oxidation number, that is a reduction. Then oxidation is the reaction that occurs at anode. So you can put anodic. So it is anodic reaction. Oxidation is nothing but anodic reaction that takes place at anode. And similarly, reduction is cathodic. So cathodic reaction. Right? Now, most of the students, they are struggling with the nomenclature of the general inorganic salts or acids or base. So for which they should be familiarized with the cations and anions. Okay, so you can come to this board and let us explain about cation and anion. So first put cation in the first column, and in the next column you can put anion. Yes, sir. Yeah. So cation means actually it goes towards cathode, so it should be positive, is it not? Anion means negative. It moves towards anode, and that is why it's called anion, right? Now, let us consider the types of cation. You can classify this into three cation: monovalent, divalent. You can branch it. You can further divide this into three. No, vertically. Monovalent, divalent, and tri or polyvalent. Monovalent, divalent, and tri or polyvalent. Similarly, you can classify anion into three: mono, di, tri or poly. So monovalent, under monovalent you can put H plus, Na plus, K plus. So these are all hydrogen plus proton, sodium ion. All these prefixes generally for cation will have IUM or OUS or IC. They have the common suffixes. Common suffixes. Okay. Similarly, in the case of anion, they have the suffixes ate, ite, for example, sulfate, sulfite, sulfide, id. You can put it as a round. So they have the common suffixes. And here, the higher oxidation states are mentioned as OUS suffix. You can mention OUS represents higher oxidation state. For example, ferrous means FeRrOUS, Fe2 plus. I'm sorry, lower oxidation state. Lower oxidation state. Higher oxidation state is represented as ferric, IC. For example, Fe3 plus. So you can mention this reaction, that is Fe2 plus gives Fe3 plus E under the oxidation. No, under oxidation. Under oxidation here in that column. Yeah. Fe2 plus becomes Fe3 plus E means Fe2 plus is ferrous. Nowadays it's called, this is ferrous ion. Nowadays it's called Fe, put Roman letter 2 ion. That is lower oxidation state. Whereas here ferrous becomes ferric is oxidation. And the reverse is reduction. Oxidation is generally represented as O. Reduction is represented as H within brackets. So you can write down on the other side under cathode, that is reduction. You can reverse the reaction. Under reduction, you can mention like this: Fe3 plus E gives Fe2 plus. This is the best way you should remember. For instance, if it is a ferrous ion, Fe2 plus, by losing one electron, it becomes a ferric ion. Okay. In this case, ferric ion, when one electron is added, it becomes ferrous ion. So this is lower oxidation state and this is higher oxidation state. And that is why you have put the decrease in oxidation number is reduction. Do you understand? So this is reduction. The increase in the oxidation number, for example, +2 becomes a +3. That is oxidation. And not only that, loss of electron is oxidation. Okay. And that is why it's simply remembered as LEO, Leo, GER. You can mention this in also separately. You can write there. Leger. Leo Gar. Leo means loss of electron is reduction. Sorry, oxidation. Leo, loss of electron is oxidation. Gain of electron is reduction. So likewise, you can remember gain of electron is reduction. Okay. Gain of electron is reduction. So this is, now let us go through the examples. Let us come back here. H plus, Na plus, K plus. These are all monovalent. Monovalent cation. Similarly, divalent cation, and it can be a combination of atom also. That is NH4 plus. Ammonium ion. Take down. Write down ammonium ion. Right? Ammonium NH4 plus ammonium ion. Okay.
Sir, in the higher oxidation state, sir.
Huh? Which one?
Loss of
Got it? Right.
oxidation.
Now, under divalent cation, so you have Ca2 plus calcium, Ba2 plus barium. You can also have manganese, Mn2 plus, cobalt, etc. And similarly, you can put the Fe2 plus also, ferrous ion. Then under polyvalent, you have aluminium, Al3 plus, 3 and above are polyvalent. Then you have ferric, Fe3 plus, etc. You can cite some examples, a few examples at least. Okay. And then you have here under anion. So under anion, you can mention that is chloride Cl minus, monovalent anion, bromide Br minus, iodide, and it can be a combination of atoms also as a group of atoms. That is NO3 minus nitrate anion. You can write down nitrate anion, nitrate. Then NO2 minus nitrite anion, nitrite anion. Similarly, we have divalent carbonate anion, CO3 2 minus, SO3 2 minus sulfite anion. Write down carbonate, this is sulfite. Sulfate anion, SO4 2 minus, that is sulfate anion. Similarly, sulfide is S2 minus. Sulfite, SO3 2 minus. Sulfite, PHITE, sulfite. And polyvalent, the best example is PO4 3 minus, phosphate. In fact, this phosphate is very popular among phosphating industries. Okay. Phosphate. Now, so we have given various examples here, but I will add some more list as PDF later. Now, we can have a combination of these ions so that we are able to produce suitable salts. So let us write on the other side. Why don't you help her yourself? Erase it.
Sir.
That's it.
Sir.
Now let us combine calcium, not calcium. Let us take sodium cation, monovalent, and chloride anion, Cl minus, is the simplest form. So this is called sodium, and this is chloride. So you can have NaCl, 1:1 ratio. This is AB type. Both of them have monovalent. So the salt is sodium chloride. Similarly, let me take calcium 2 plus, calcium, and Cl minus, that is chloride. So in that case, this is 2 plus, this is minus. You can multiply this by 2, because when you combine the ions to get the molecule of no charge, it should be neutral. So the charges should be balanced. So here you have Ca2 plus and this 2Cl minus. You have to multiply by this 2. So that 2 minus 2 plus cancel. Now you can put Ca, Cl, at the subscript you have to put 2. Right? So this is calcium chloride. Take down. Here I would like to mention one important point. Let me represent any element by X. Right? So on the left side, you had to mention at the subscript the atomic number. Z is atomic number. And at the superscript, left superscript, you have A, that is the mass number or atomic mass. On the right, you have to mention the charge as oxidation number. And at the right subscript, you have to mention atomicity, that represents the number of atoms in a molecule. Right? For example, let me consider Cl2 here. So what does it represent? It consists of 2 atoms in this molecule, calcium chloride. For example, let us take calcium chloride as a whole. Okay? And let me put here uranium 92 to 35. Then let me put here O2 minus. Here O2. Now, calcium chloride. What is the atomicity of calcium chloride? Because I already represented X, here Z, here A, and in this case, charge, here atomicity. Now, I am asking you, what is the atomicity of chlorine in calcium? The atomicity of chlorine in calcium is 2. Got it? Take down, put box. And what is the atomicity of calcium here? It is 1. Got it? Similarly, now let us consider this uranium 92 235. What is the atomic number of uranium? Atomic number of uranium is 92. What is the atomic mass of uranium? Atomic mass of uranium is 235. Okay. And similarly, let me come back to calcium chloride. What is the atomicity of calcium chloride? In that case, I have not mentioned any element separately, instead as a molecule. So you have to count the entire number of atoms. So 2 plus 1, 3. So atomicity of calcium chloride means 3. Do you understand this? Now, what is the oxidation state of oxygen in oxide anion? 2 minus. Okay, so you have to put oxidation number is -2. Its charge is -2. Okay, is it clear? Then Now, what is the atomicity of oxygen in oxygen molecule? 2. I hope now you should be able to understand these points. Let me take another H2SO4, sulfuric acid. I think you should take another chalk. This is not good. You can avoid that chalk. You can well. Continue. Oxidation state of, I mean, not oxidation state. Um, Let us consider sulfuric acid, H2SO4, put right there. H2SO4. What is the what do you call the oxidation, not oxidation state, atomicity of oxygen in H2SO4? 4. H2SO4 means oxygen, only oxygen. Atomicity of oxygen in H2SO4, 4. Atomicity of sulfur, atomicity of hydrogen, 2. Right. Okay. Are you able to follow this? Just a minute. Next. Now let us move to, then you can erase entirely. Let us have, let us combine Ca2 plus SO4 2 minus. In both the cases, it is 2 plus 2 minus, so you can straight away write this as Ca2SO4 twice, which is nothing but CaSO4, calcium sulfate, because 2 can be cancelled. So you can simply put CaSO4. Let us consider Na plus NO3 minus gives NaNO3, sodium nitrate. Now, these ionic equations can be effectively utilized to name the compounds also. For example, let me reverse. I have got calcium nitrate, CaNO3 twice. So just by looking this molecule, we can name it calcium Ca. So put calcium, and this is nitrate. So we can combine nitrate, calcium nitrate. Now I have got the name how to write down the molecular formula? So this is calcium. You can write Ca2 plus. Nitrate, we know it is NO3 minus. Now you have to balance it. So this is twice so that you will get the neutral charge. Then you can put comfortably CaNO3. You have to put twice like this. So this is the way you have to arrive at the molecular formula. Got it? I will give you some exercise. Try to do that. Take down. You can write here. Sodium carbonate. Can anyone write? Sodium carbonate. How to write sodium carbonate? Sodium is Na plus. Carbonate is CO3 2 minus. So this is plus, this is 2 minus. So you have to multiply by this 2. You can establish the ionic reaction. So Na2, that is this molar coefficient, should be written as atomicity. So Na2, then you can put CO3. That's all. So this is the way you have to write down the molecular formula. Is it clear? Can you write down calcium carbonate?
CS.
How to write down calcium carbonate? Calcium is Ca2 plus, CO3 2 minus. Straight away you can put CaCO3. What is this type? AB type or A2B2 type. Otherwise you can call it AB type. Okay. What about this one? This is A2B type, correct? Because cation it has got plus 2. Okay. Then similarly, I have got barium sulfate. Can you write the molecular formula for this? Ba2 plus SO4 2 minus. Very good. So both of them are 2 plus and 2 minus. Straight away you can put. So BaSO4. I'll give you another typical example. You have aluminium Al3 plus and the phosphate PO4 3 minus. Now what could be the formula? Both of them are 3 and 3 minus. So straight away you can write down as aluminium phosphate AlPO4. That's all. Right? Let me declare calcium phosphate. Calcium phosphate. Now we will try to obtain the molecular formula. What is calcium? Ca2 plus. Plus what is phosphate? PO4 3 minus. Now we have to balance it. Okay. So you should get neutrality of charge. In that case, this calcium can be, what is the LCM between these 2 and 3? 6. So this can be multiplied by 3 and this is multiplied by 2. Okay. So you can write down as, forget about charges because it's already neutralized. 3 2s are 6 plus 6 minus. So 3Ca, you cannot write 3Ca, instead Ca3. Then PO4, you cannot simply put PO4 2, it becomes 42. It will be confusing. So PO4 twice. Like this, you have to mention. Okay. So now we have obtained the formula for calcium phosphate. And can you write down the molecular formula for ferrous phosphate and ferric phosphate? So ferrous means Fe2 plus PO4 3 minus, that is a phosphate. Now similarly Fe2 3 minus means you can multiply this by 3, this is by 2. Why? To get the neutral charges. So 3 2s are 6, 2 3s are 6. So you can write down now Fe3 PO4. So this is the way you should be able to obtain the molecular formula. And similarly ferric phosphate, Fe3 plus ferric, and this is PO4 3 minus. In that case, Straight away you can put FePO4, that's all. Okay. I hope now the point is very, very clear. Now I will talk about some, that is a basicity in acids also. Let me have three types of acid: HCl, H2SO4, H3PO4. So HCl can ionize as H plus Cl minus, whereas H2SO4 in the first stage it can become HSO4 minus plus H plus, and in the next stage HSO4 minus further releases one H plus to become SO4 2 minus. So this is capable of releasing one H plus. So HCl is capable of releasing one H plus. Sulfuric acid is capable of releasing 2H plus. So that is why it's called dibasic. But it happens in two stages. One H plus, another H plus. So that is why this HSO4 minus results monobasic salt. Monobasic salt. And SO4 2 minus results dibasic salt. And that is why the basicity of H2SO4 is 2. In this case, the basicity is 1 because it is capable of releasing one hydrogen. Whereas in this case, it can release 3H plus, so that it becomes tribasic salt, PO4 3 minus. Okay. So here the proton transfer is 3. Okay. I hope now you are very familiar with the oxidation states.
Phosphate PO4
PO4 3 minus. Right? Now, so what we have discussed so far, that is, we know what is the oxidation reduction and what is oxidation number. Oxidation number, write down. Then we know the charges, that is different types of cations and anions, and fourth is we know how to balance the ionic reactions, and based on that how to name the compound and arrive at the formula, name the molecule, naming the molecule and forming the molecular formula. Now let us determine the oxidation number. How to determine the oxidation number? Oxidation number, naming the molecule and forming the molecular formula. Then finally, we will discuss the oxidation number and how to balance the redox reactions based on the oxidation number. Now let us move to oxidation number. For hydrogen plus ion, it is plus 1. For hydrogen minus ion, this is called hydride ion, it is minus 1. For sodium plus ion, it is plus 1. For chloride minus ion, it is minus 1. For any neutral atom in the fundamental state, natural state, it is 0. For example, gold, natural state 0. If it is Fe as natural state, 0. And if it is FeCl2 as molecule, neutral molecule, it's 0. Neutral molecule, 0. Not down. Neutral molecule. Suppose neutral, put neutral molecule. In case if it is Fe2 plus, then you have to mention plus 2 is the oxidation state. If you put Fe3 plus, then you have to say plus 3 is the oxidation state. So by knowing the familiar oxidation number, you can find out the unknown oxidation state by algebraic sum. For example, let me take up KMNO4. This is called potassium permanganate. Take down. Potassium permanganate. So its ionization will be like this. K plus and then MnO4 minus. So what is this? Potassium cation. And this is permanganate anion. Write down permanganate anion. And you should also note down K2MnO4. This is called potassium manganate. And here it ionizes as 2K plus MnO4 2 minus. So this is manganate. Are you able to find out the difference between permanganate and manganate? If it is manganate, it is MnO4 2 minus. If it is a permanganate, then it is minus. Right? Write down manganate anion. Now, I want to determine the oxidation state of manganese in potassium permanganate. Put X for this. We know the net oxidation number is 0 for any neutral molecule. Got it? For potassium, it is plus 1. For oxygen, it is minus 2. Now you can work out plus 1 plus X plus 4 into minus 2, right? That is equal to 0. So plus 1 plus X minus 8 is equal to 0. X minus 7 is equal to 0. X is equal to plus 7. So you have to determine, you have to write like this. Oxidation number of manganese in KMnO4 is plus 7. Okay. Shall we try to find out the oxidation number of manganese in K2MnO4? K2MnO4. So here for K we already know plus 1. For oxygen we know minus 2. So put X for manganese, underline. Now 2 plus X minus 8 is equal to 0. Got it? So X minus 6 is equal to 0. X is equal to plus 6. So here it is different. Okay. So X is equal to plus 6. KMnO4, the net is oxidation state is 0. Net oxidation state is 0. So X minus 6 is equal to 0 means X is equal to plus 6. So here you have to write down oxidation number of manganese in K2MnO4. You must remember this as plus 6. So here it is plus 7, here it is plus 6. Let me take another compound, that is manganese sulfate, MnSO4. How can we split this manganese sulfate? It is going to be ionized as Mn2 plus SO4 2 minus. So in that case, the manganese is plus 2 because you can split like this. For SO4, the oxidation state is minus 2. So x minus 2 is equal to 0 means x is equal to plus 2. Instantaneously input. Okay. Are you able to follow? Now let us find out what is the oxidation state of sulfur in H2SO4. Put sulfur as X. And this is plus 1, oxygen minus 2. The net is 0. So plus 2, 2 into 1, plus x, 4 into minus 2, minus 8, 0. So x minus 6 is equal to 0, x is equal to plus 6. So the oxidation state of sulfur in sulfuric acid is plus 6. Okay. What is the oxidation number of chromium in K2Cr2O7? Potassium dichromate. So Cr put X, potassium plus 1, oxygen minus 2. So 2 plus 2x minus 7 2s are 14 is equal to 0. Therefore 2x minus how much? 12 is equal to 0. 2x is equal to 12. X is equal to plus 6. So the oxidation state of chromium in potassium dichromate is plus 6. Got it? Similarly, let us derive for Cr2SO4 thrice. Chromium sulfate. So here, for sulfate, we know minus 2. Got it? For sulfate, it is minus 2. So put X for chromium. So 2x plus 3 of minus 2 is equal to 0. So 2x minus 6 is equal to 0. 2x equal to 6. X is equal to plus 3. So in this case, chromium has got plus 3 oxidation state. So from this is obvious that elements like manganese, chromium, they can have variable oxidation states. Are you able to follow? Okay. For example, I have manganese, MnCl2. What is the oxidation state of manganese in MnCl2? The net is 0. Molecular formula MnCl2. So x plus 2 of minus 1 because for chlorine minus 1. So x minus 2 is equal to 0. X is equal to plus 2. So likewise, this manganese and chromium, they are capable of forming various oxidation states. That is the specialty of D block elements. Okay. Now let us proceed with, I hope now you should be able to identify the or determine the oxidation number. Okay, you can erase this. Erase this. Now let us proceed with balancing of redox reactions. Balancing of redox reactions. Using oxidation number method. You can remove that arrow mark. Balancing of redox reactions. Now, let me give you the reaction KMnO4. This is an acidified KMnO4. You can put H2SO4. And then oxalic acid, H2C2O4 is oxalic acid. So that gives K2SO4 plus M1SO4 plus CO2 plus H2O. So we can apply the oxidation number technique to balance this redox reaction. For example, let us identify. First step is you can write down the steps here. Some of you can go there and write down the step. So let Priya write down the mechanism and you can write down the equation. Come. Now, write down. Let me give the clue here. Step 1. What is step 1? Determine the oxidation number. Determine the oxidation number. You write down. So you have to determine the oxidation number of atoms, or you can say elements. Elements. Determine the oxidation number of elements that undergoes change in oxidation number. Change in oxidation number. Determine the oxidation number of element that undergoes change in oxidation number. What do you mean by that? Now, potassium, it is not going to change. Hydrogen does not change. Oxygen does not change. So in that case, let me underline, manganese will change. And then carbon will change. So in this case also on the product side, manganese and carbon. Now I have identified the elements undergoing change in oxidation number, for which we had to find out the oxidation number. So can you write down the oxidation number of manganese in KMnO4? We already done. What is that?
7.
You can put here plus 7. We already done. And can you write down determine the oxidation number, Priya try, for carbon in oxalic acid? Put X. You can do like this, H2C2O4. Put X for that. This is plus 1. This is minus 2. Do it. So plus 3. You can write down plus 3. Take down. Write down plus 3 above carbon. And identify the next manganese here. Manganese sulfate. What is the oxidation state for manganese? Sulfate is minus 2 and this is plus 2. So you can put simply plus 2. Then what is the oxidation state of carbon in carbon dioxide? O is minus 2.
4.
Very good. So plus 4. Okay. Now what you can do? Plus 7 becomes plus 2. Put the arrow mark like this. So you can write down in the second stage. Take down 2. Step 2. In the next step, identify oxidation and reduction. So reduction is represented here. That is plus 3 becomes plus 4. Is it not? Because I already mentioned that when I defined the oxidation and reduction, increase of oxidation number is oxidation. Decrease of oxidation number. So we can put here decrease of oxidation number. So H, reduction. Increase of oxidation number, that is oxidation. So we have mentioned, determined. That is step number 2, right? Then we'll go to step number 3. Identify the number of electrons transferred. Identify the number of electrons transferred. Okay. So let us identify. Plus 7 becomes what? Plus 2. So how many electrons are transferred? 5 electrons. Whether it is added or removed. added because E is minus. So you have got plus 7, write down plus 7. So this plus 7 becomes a plus 2 means 5 electrons are added. Okay. So addition is represented by upward arrow. Addition of electron by upward arrow. Removal of electron by downward arrow. Okay. Addition of electron, upward arrow. So in this case, addition of electron is nothing but reduction. You can mention, is it not? De-electronation, removal of electron, loss of electron is oxidation. Now, what about carbon here? Plus 3 becomes plus 4. How many electrons are removed? Dropped. 1 electron. So 1 electron is dropped, but there are 2 carbon, no? So you can put 2 into E, 2 into 1 electron. Write down here itself. Put arrow mark and do it. Put arrow mark. Oh. Okay, got this point? Now what you are supposed to do, you have to interchange the number of electrons transferred. Next step you can introduce. Fourth step, interchange the number of electrons transferred as molar coefficient. Write down. Interchange the number of electrons transferred as molar coefficient. Now listen to me. How many electrons are there? 2 electrons. So you had to put for KMnO4, 2 KMnO4. Got this point? Are you able to understand? So I have put the 2 electrons as coefficient of KMnO4 as 2 KMnO4. Got it? And plus you can put nearby. And what about this manganese 5 electron? So this should be applicable to H2C2O4. So you can put 5 H2C2O4. Okay? 5 H2C2O4. Then you can put H2SO4 and the remaining K2SO4, MnSO4, CO2 and H2O. Got it? So once you have transferred that is interchanged the number of electrons, underline, you should not touch it unnecessarily. Now balance the remaining number of elements or compounds with the ERP method. ERP method means E element or reactant product P. So you can write down like this. Balance the remaining part by ERP method. Okay. Now you can put ERP, Priya. Put ERP like this. Priya, what you are supposed to do, you have to list out the elements. Okay. So list out the elements starting with the cation followed by anion that are distributed widely should be given the least priority. Okay. If any atom, for example, let us identify an atom like oxygen that is distributed widely, is it not, in various places, that should not be given the priority. It should be given least priority. Put it at the bottom most. Okay. So other cation, for example, let me consider potassium, then manganese, and then which is least distributed here? Carbon, and then sulfur, and then hydrogen. Sulfur, hydrogen, then finally oxygen. Got this point? Okay. So you have to put like this. Put comfortably horizontal lines also. Now, what you are supposed to do? How many potassium atoms are there in reactant product? You have 2, because 2 came in a 4. 2. And on the other side, product side, 2. Then manganese, how many? 2. And on the product side, 1. And what about carbon? 5 twos are 10. You can put 5 into 2. And what about here? Only 1 on the product side. And then on the product side, I mean reactant side, sulfur, how many sulfur? 1 sulfur. Here, you have to put 1 with gap, then 1 sulfur.
1 plus 1.
1 plus 1. Now leave some gap. You have to put, you cannot put 2 immediately. Put 1 plus 1. Then hydrogen, how many hydrogen? 5 into 2 hydrogen. Am I right? Plus, put bracket, then plus, have one hydrogen. I mean 2 hydrogen in sulfuric acid. Is it not? So 5 into 2 plus 2. Then what about the other side? You have only two hydrogen in water. Okay. And finally, oxygen. How many oxygen? 2 into 4 plus 5 into 4 plus 4. That's all. On the right side, you have 4 in K2SO4 plus leave some space. 4 in MnSO4 and then oxide, carbon dioxide 2 plus water 1. So likewise, you had to split it. Now let us proceed. So there are 2 potassium, 2 on the reactant side, 2 potassium on the product side. Tick. That is balanced. And what about manganese? This is 2, this is 1. So multiply this by 2. Now you do one thing. When you multiply here, go straight yourself. Go straight. Where is this manganese available? Where is this manganese available? On the product side. Multiply by 2. When you multiply, what are you doing? You are multiplying sulfur also. Is it not? Underline sulfur and also oxygen. So you have to account for that. Now what you are supposed to do? Go to sulfur. First sulfur. Is it not? First or second sulfur. So second sulfur you can put multiply by 2. Put bracket. Done. Okay. Now don't do anything. And then what about oxygen? Where is this oxygen? Second oxygen or on the product side? She has touched second oxygen, MnSO4. So where is it? You can move a little bit. Where is the second oxygen? Second oxygen into 2. Into 2. Okay, so you should write legibly, ma'am. Then, and then, now sulfur is over. So here 2 into 1 sulfur, but here only 1. And what about hydrogen? Identify hydrogen here. Okay. So here 5 into 2 and then here 2. Is it not? So 5 into 2 means 10 and here 2. So totally 12. And before that we have to work out the sulfate. How many sulfate? 2 plus 1, 3. So you have to multiply this by 3. Sulfur multiply by 3. Listen here. Sulfur on the reactant side multiply by 3. Okay. So in that case, you have to multiply the hydrogen also. Is it not? Put 3 into 2 on the reactant side. Okay. Right. And the reactant side 3 into 4 into 3. Okay. For oxygen into 3. Got it? Better you do one thing. Erase completely. Rewrite ERP. Otherwise, you will not. Yeah. Leave that portion. Write boldly ERP. Give enough space. Copy everything. So potassium, manganese, carbon, sulfur, hydrogen. Rewrite everything. 2. We already done. Tick mark. Put tick mark. Put tick mark for carbon. Sulfur. Okay, so sulfur is also balanced. Give enough space for oxygen. 2 into 4, 5 into 4, 3 into 4. Oxygen. On this side, 4 plus 4 into 2 plus 2 plus 1. Okay, now listen. So let us come back. Potassium, that is salt. Manganese, put tick mark, balanced. And what about carbon? 5 into 2, 10. So here multiply by 10. And you can also do that. 10 carbon on this side. Put 10 carbon. Whenever you write any chemical equation, leave some space to introduce the molar coefficient. Okay, otherwise it will be too crowdy, mess up. Now, so 10 into 1, 10. Done. Okay, you can put a tick mark. And you can underline also. Once balanced is 10 CO2 balanced, but you have to put 10 into O2. Is it not? So where is oxygen? Put 10 into on the right side, product side.
Less than.
Product side on 2. What are you doing? 2 into 10. Oh, then plus 1. Okay, done. So that is over. And now what about sulfur? That is also balanced. Is it not? So check sulfur. Is it balanced? 2 plus. Put underline 3 H2SO4. Underline 3 H2SO4. And 3 hydrogen. 3 into 2. Put the bracket. Put the bracket. Then for oxygen, 3 into 4, is it not? Put the bracket. Right. Now, work out the hydrogen now. How many hydrogen?
3. The reactant side 10, 16.
16 into 8. Put 8. 8H2O. Okay, got it? So, hydrogen is also balanced. Put tick mark. Hydrogen balanced. So, and you have to multiply by 8 other oxygen. You check the oxygen, automatically it is balanced. Please check. 40 oxygen, is it not? Put 40 oxygen, put 40, round. Put round, 40, round. And work out here. What about oxygen? That is also 40, is it not? Put round. You can move a little bit. Okay. Now the entire equation is perfectly balanced. Are you able to follow? Put tick mark. So this is the way you have to do. Using oxidation number method. Do you understand now? So this is with the help of this you can balance any complicated oxidation redox reactions. Okay. So from this reaction you should be able to identify the oxidizing agent and reducing agent also. So can you identify the oxidizing agent here yourself?
KM.
KMNO4. Very good. Put OA. That is the oxidizing agent. KMNO4. OA. Round. And which is the reducing agent? Oxalic acid is the reducing agent. RA, reducing agent. That's all. Now, believe me, oxidizing agent, write down. Oxidizing OA undergoes reduction. You just check whether undergoes reduction because plus 7 becomes a plus 2 means reduction, is it not? And what about reducing agent that undergoes oxidation? Okay. So these things you have to be very, very careful, right? So in this session, I was able to explain very nicely the balancing of redox reaction. But just by doing one exercise, you cannot, get the skill of balancing the chemical equation, especially redox reaction using oxidation number method. So you have to do many number of problems like this, I'll give some exercise. Try to do all those things. Okay. If there is any doubt, you can ask me. Okay. Right. So thank you for your patient listening.